project is a self-monitored and adjusting greenhouse system. It's marketed for anybody that wants to go through vegetation, an environment that is constantly monitored and adjusted. And since it's an automated system, people can rest assured that the plants are growing at peak efficiency without having to constantly be tending to the plants themselves in the greenhouse. We're using an Arduino microcontroller. I think it says, Arduino microcontroller. And we're going to be controlling our outputs with a series of relays that Arduino's going to control the ground for. So we've got several higher voltage actuators, and we don't have one on the same circuit as the controller, obviously. We're monitoring several parameters as inputs. We're doing interior humidity and exterior humidity, interior and exterior temperature, soil moisture, and some presence of solar irradiance. And I'd like to go over a few of the inputs and outputs. As far as interior temperature, we're measuring inside and outside. We figure that if the temperature inside isn't what we want to, but the outside want it to be, the outside is ideal, we can just vent that so we don't have to spend waste electricity on heating or cooling. If the temperature is not where we want it to be, let's say it's too cold, we're going to use an electric heater and fan to raise the temperature. And if it's too high, we're going to use some backward cooler, small cooler to lower the temperature down. As far as the humidity, we're going to do the same thing. We're going to measure the interior and exterior humidity. And again, if the outside conditions are ideal, we're just going to let that humidity ride out the venting system. If they're not, if they're too low, we're going to raise it up with a humidifier. As far as the soil moisture, we're going to use a dual probe sensor that fits in the soil and basically measures the difference in potential in the soil. So if there's moisture in the soil, we're going to have lower potential voltage. There's going to be more current flowing, so we're going to interpret that as wet soil, and we don't need the water. But if the soil is dry, then we're going to need to actuate a drip irrigation system and until the soil reaches spec. And as far as the solar irradiance, we're not really going to be measuring the intensity of it. We're going to be looking for the presence of it. We want our plants to get at least 14 hours of sunlight a day. So we're going to be logging that time. How long have we been reporting sunlight for the day? And based on that, if we get at least 14 hours in the log, then we don't need to do anything. But if there's less than 14 hours, then we're going to turn on some grow lights and make sure those plants get the light they need. In the next semester, we're going to try and implement solar panels, a series of batteries, and possibly a water collection system to make the greenhouse itself more self-sufficient. Are there any questions?
Have you considered monitoring pH?
We did not consider monitoring pH.
I guess it's just out of curiosity, a lot of solar people are doing hydroponics, aeroponics, things like that. pH is probably a good sensor. I think there's pH sensors for everything.
Right, that's not something that we had thought about, but that's something we could potentially look into for the next semester. So maybe more well-rounded.
You can take several measurements and then based on threshold take several time. How do you decide that 75 degrees is too hot or too cold? So is it based on experience and you experience with greenhouses or so how do you decide what are the actions that you want to implement based on
We did some research on it, and we were thinking somewhere between 60 to 90 degrees inside the greenhouse. So we're just going to go in that way because we're going to be looking for that.
Yeah, there's a lot of literature out there with the range that you want to try to keep your greenhouse within. There's a safe zone.
for example, the sensor is talking about temperature inside. So why do you need temperature outside to keep 60 to 60 right now?
Why do we need to keep it in that temperature range?
No, why? So that refers only to temperature inside. What's the objective of measuring the temperature outside?
Oh, right. Okay. So if we're trying to conserve electricity by doing that. If we know the temperature outside, and it's an ideal temperature. Let's say we want the greenhouse temperature to be the exterior temperature, but it isn't that way inside. Then we can go ahead and vent to the atmosphere. We can bring that air in, either push the hot air that's in the greenhouse out or pull the warm air in and raise it to that temperature, the ideal temperature that we already have outside. That way we don't have to go and worry about either using the swamp or the evaporative cooler. We don't have to worry about using the heater to adjust the temperature inside the greenhouse.
Do you have an evaporative cooler as part of your prototype?
We don't have an evaporative cooler as part of our prototype right now. It's really not, we've looked for small ones. Obviously, it's going to be very, very hard to find something that small that's evaporative cooler. So it's something that we're actually going to have to build ourselves. But we will have it in the second semester.
Who's doing what, and how are you going to demonstrate it?
We're gonna build a little model of this greenhouse. It's gonna be around like 2 feet. And we're gonna, we put a little model outside. And it's gonna have all these sensors. We're gonna have 2 zones. And we're gonna be getting visual orders.
Right. It's going to be, there's going to be a plexiglass greenhouse, basically a scale model of the actual system in place. We're going to have the drip system laid out. We're going to have all our sensors in there, and we're going to demonstrate simulated dry condition of the soil, and we'll probe out the soil, simulated dry conditions so that everybody can see the drip system actually turns on and starts working. So we'll have a scale model, a scale working model of everything.
Question?
No, that was my question on demonstration.
All right, so, yes.
I was just wondering, what constitutes success for you in the project? What would make this a success?
There's no plans directly.
Because you can have an automated system with anyone.
Just so that there's big for it. That's what we're doing.
That all of our, the measurements that we take our actuators correctly, if they're out of range that we want, the actuators do their job and bring the greenhouse to desired specification of temperature, humidity, soil moisture. If they can, if the actuators can correct the environment in the greenhouse exactly where we want it to be, that will be success for us.
All right, so, thank the speaker.